Okay, we're back. Here, let's take a look at this one problem, and I'm going to go ahead and, because me, instructor, I can open up all these hidden parts, okay, for this video. Okay, so here we have unpolarized light of intensity IO is incident on a polarizer analyzer pair. Okay, so we've got light coming in, polarizer analyzer pair. If the angle between the polarizer increases in the range from 0 to 90, the transmitted light intensity, will it increase, decrease, or remain the same? In other words, what are we talking about? What are you talking about, Woo? Here we go. So this is problem 2450. You got a polarizer. You got an analyzer. You got your light coming in here, I naught. It goes through the polarizer, and it's cut in half. Now, if this analyzer is perfectly perpendicular with the polarizer, then it's just going to come through at 1/2. But if it's at an angle, off the normal again, so it's at an angle like this, then what you wind up with is 1/2 I naught times the cosine squared of theta. That is Malou's law. Well, of course, anytime you multiply by a cosine, what's the cosine? It varies between 0 and 1, right? Or 0 and -1, or -1 and 1. So cosine, but in this case, when it's between 0 and 90, it's going to be between 0 and 1. And so it's actually small. And then we're squaring it. So when you square a number less than 1, you get a really small number. So, of course, it decreases. All right? Just wanted to kind of beat that to death. So I'll let you all pick that out. But anyway, so and then I'll just do this first one, part C. Well, it's because the vertical components start to get removed. Vertical components of the intensity start to get removed. That's what I think. But anyway, all right. So now we need the IP and IA. Now notice they don't say how many of sig fig, so use 3, right, in this, and I'll just do the first one here. So if the angle between the analyzer and polarizer is 39 degrees, what light intensity would be transmitted through the polarizer and analyzer respectively in terms of IO? See, in terms of the intensity. So let's go and look at that real quick. What do they say? Theta is equal to 39 degrees. Well, this isn't hard. So IO comes through, and then it's 1/2 IO, and then it's 1/2 IO. So this is going to be in terms of IO, 1/2 IO times the cosine squared of 39. All right. So here's the polarizer. Here's after the analyzer. After the polarizer, it'll just be 0.500. After the analyzer, it'll be 0.5 times, and this is the way I do it on my calculator, cosine of 39, close the parentheses, squared IO, because we want it in terms of IO, and you're done. And you'll do the same thing on the next one. And problem 46 works the same way, I think. We'll take a look at it.